When we use Wireshark to capture network packets, in most cases, we are only interested in the regular network data, but when we troubleshoot some Wi-Fi specific issues, such as roaming or connectivity issue, sometimes we want to see the 802.11 packets header, but if you try Wireshark in the normal way, you will have trouble to successfully capture those type of packets. In this video, let's talk about different approaches and let's check whether they work or not. On Wireshark website, you can find this documentation. It may tell you why you fail, but you may still have problem to successfully capture the Wi-Fi packets you need. Ethernet is covered by IEEE 802.3. Wi-Fi or W1 is covered by 802.11. In real-world implementation, the Wi-Fi adapters in our computers or Wi-Fi devices, they always fake the data packets into Ethernet packets. When operating system receive those packets, the operating system simply use the old good Ethernet way to process them. Life is good. That's why if you use the normal way in Wireshark to capture wireless packets, you won't see the 802.11 specific header information. This is what we are going to focus on. In this video, I will go through 6 different approaches. Let's see how they work, which one is feasible and which one doesn't work at all. First approach, I'm going to use old Apple hardware and old macOS. It is able to capture what we want. Approach 2, I'm going to use the M1 MacBook Pro with the new macOS. You will see it failed miserably. And the third approach, capture the packets within the AP instead of in the client. You will see, yes, it will be able to capture something, but not what we want. And in the fourth approach, it is successful, but not very convenient. In this way, I'm going to first use Sniffer, which comes with macOS. Once the file is captured, I'm going to use Wireshark just to view it. Then I'm going to investigate to see what really caused the approach 2 failed and what makes approach 4 work. And then let's see whether we can get a convenient and working approach. In the end, I will show you how I do it in Linux environment. Before going to the system to show the different approaches, I would like to talk the 2 different modes briefly. These 2 modes are very important when it comes to Wireshark's packets capturing. The first one, Promiscuous mode. I believe most people, as long as you use Wireshark, you know this. Basically, like it's mentioned in the Wikipedia article, it will pass all traffic instead of the ones which are designated to the particular client machine. About the monitor mode, this mode is specifically related to the Wi-Fi or 802.11 packets capturing. If you don't enable the monitor mode, in most cases, for most hardware and software, you will only capture the fake Ethernet packets instead of the 802.11 packets. That's why you need to enable monitor mode. Let's talk about how I'm going to demo the approaches. Use this approach as an example. I'm going to show you the Wireshark running on a old Apple hardware, old Apple OS. At the same time, I'm going to use an iPhone. I will move from the AP2 to AP1. Both the iPhone and the Mac Pro computer will be connected to the same SSID. Let's see what packets can be captured from Wireshark. As you can see, the Mac is a 2008 Mac Pro running macOS El Capitan. In Wireshark, choose the Wi-Fi adapter. You can see the Promiscuous mode and monitor mode. They are both selected by default. So now I already started capturing. I put a filter on the MAC address of my iPhone just to make sure we only see the packets we are interested in. Now I'm holding the iPhone, moving from AP2 to AP1. You can see the packets are being captured in real time. Okay, I disconnect the iPhone from Wi-Fi. Let's see what packets were captured. You can see in protocol column, most of the protocols, they are 82.11. So the capturing was successful. Let's examine the packets. The very first three, they are probe request, then authentication, association, then four-way handshake to generate encryption key. Move to the end. When I disconnected iPhone from Wi-Fi, you can see it's the de-authentication packet. It seems this approach works perfectly, right? So we don't need to change any configuration and Wireshark work right away out of box. But you know what? There's a problem. It has very limited usage because you can only capture the exact channel frequency SSID which your Mac is currently connected with. You cannot say, okay, I connect to this Wi-Fi, but let's capture the packets from another SSID, from another channel. It's not doable here. Move on to approach 2. It's almost the same as approach 1. The only difference is I replaced the computer with a Apple M1 MacBook with newest operating system. This is the hardware and software version for this MacBook. Start capturing. Okay, you can see the monitor mode and the promiscuous mode. They are both selected. We are good. Start. Here I don't have any filter. In fact, I was moving the iPhone from the AP2 to AP1. There are supposed to be many packets, but nothing is captured. In the whole process, there's no error message from the OS, from Wireshark, so it's a complete failure. Okay. Now let's talk about the third approach. In this approach, we are going to use the Ubiquiti's recommended approach. We are going to go to the Ubiquiti UniFi access points, run command there. It sounds to be a very promising way, but I simply cannot make it work. So in this screen layout, I show you 4 windows. This one is for UniFi controller. You can see the current topology, including the Wi-Fi clients. I'm going to run SSH into the access points. In this terminal, I'm going to run some command in the local Mac machine. And in the lower left window, you can see the Ubiquiti's official document telling you how to run the process. If you check this Ubiquiti help document, go to capturing traffic with TCP dump. It shows you within the access point what command you can run to capture a file, and then later you can view the file. Because the UniFi access points come with this TCP dump support, you don't need to install any extra software. It is supposed to be working to meet our requirement to capture the 802.11 packets, right? Let's try it. You can see I have 2 access points. Remember, I'm going to move the iPhone from AP2 to AP1. Our target is AP1, so I want to capture the Wi-Fi packets for AP1. Let me click it, AP1's IP address. Let me SSH into the AP. Okay, I'm in. To run this Ubiquiti's TCP dump command, you need to know what's the interface for your particular SSID. So the way to tell it is very simple. You run iwconfig. In my current situation, you see several radio interfaces, but the RAI0 is the one I want to connect my iPhone to, which has this SSID. Now I know the interface name, which is RAI0, right? I can start capturing. From the network controller, you can see the iPhone is connected to AP2. From the AP1 SSH, let me run the Ubiquiti's recommended command for TCP dump. By the way, if you are familiar with the Wireshark packets capturing, you may know for the remote capturing, there's an easier way. You can run SSH from the client and establish a pipe. The capture data can flow from the remote AP to client, so you don't have to save a temporary file. But I'm only going to show you the basic steps. From the AP, I run this command, capture this particular interface. Target is this temporary file, right? Let me run it. Okay, it's listening, and the iPhone is still connected to AP2. Now let me move the iPhone to AP1. You should be able to see the effect in real time. As you can see, the Wi-Fi roaming happened already. iPhone now is connected to AP1, right? Then we are good. Then in the SSH session, let me kill the capturing. The way to kill it is just Ctrl+C. Okay. It's done. In my client, the Mac machine, let me simply get the file. I prefer SCP. So I simply run SCP. Source file is in the AP in this folder, and the target is my local Mac machine. Input your SSH password. Okay, it's transferred successfully. Now I have the file. Now let me find the file and then open in Wireshark locally. I double click the file in my local Mac and open captured file in Wireshark. Let's just check the protocol column. You can see nothing about 802.11 was captured. Everything is about Ethernet packets. That means it doesn't capture what we want, the Wi-Fi packets. It's simply capturing the non-monitor mode packets. But I still want to figure out, okay, whether from the AP I'm able to capture the 802.11 packets in monitor mode. So let me go back to the AP. See this SSH session. The way we run the command is just specify the interface, right? If you are familiar with TCP dump, you may know it does support a parameter which is capital letter I. So the capital letter I means I want to capture in monitor mode. That's exactly what we want to do. Let's see whether I can do that. See the error message? That device doesn't support monitor mode, so it failed. I cannot capture Wi-Fi packets in monitor mode. This is disappointing because that's the native UniFi AP way I do want it to work. Remember, in approach 2, we used the latest Apple hardware and software. It failed without any error. It just simply didn't capture anything. This time, let's use the exact same hardware and software, but try to capture the packets differently. From the UniFi network controller, you can see now I have the iPhone connected to AP2. Let's try to start capturing. Let's use the built-in macOS functionality to capture the Wi-Fi packets. I hold the Option key on the keyboard, click the Wi-Fi icon in the menu bar. You will see the menu item is different than normal display, right? I simply click the Open Wireless Diagnostics. Ignore this dialog. Go to the menu item window, sniffer. This is what we want to run. Basically, it's just a UI for a similar tool like Wireshark or TCP dump. But here it asks for two information, the Wi-Fi channel and the width. The way to find it out is go to network controller. Remember, I'm going to move the iPhone from AP2 to AP1. Let me go to devices, click AP1, go to WLAN. You will see for the SSID I'm going to connect to, the channel is 149, the width is 40. That's how you get the information you need. Here in the sniffer dialog, choose 149 and 40. And start capturing. Okay, it started. Let me move my iPhone from AP2 to AP1. I already moved the iPhone to the new location. Go to the topology, make it bigger. This UI has some delay because on my iPhone, I already see the Wi-Fi signal changed. That means the roaming was already successful. But from the network topology, it's still connected to AP2. Give it some time. Once it's refreshed, I will stop the sniffer. See the display is refreshed. Now iPhone is connected to AP1, right? The sniffer is still running. You can tell from the spinning icon. Let me stop it. The file is captured in VAR temp folder. macOS Finder simply doesn't show you that particular folder. Let me launch a Finder. Go to folder. Simply type in VAR TMP. Now I'm in the folder. You can see there's a PCAP file captured. Double click it. Wireshark is associated with this file extension, so it's opened using Wireshark. As you can see, there's an arrow. You can ignore it. Simply say the very last packet is not complete. If you pay attention to protocol, you can see now all the packets are 802.11 packets. That's exactly what we want. So we have successfully captured the Wi-Fi packets. Just show you several special packets which are related to my iPhone roaming. When I try to start the roaming, you see the authentication packets and then reassociation packets, authentication handshakes. After the connection is established, then there are some normal communications. You see the 802.11 protocol and EAP related protocol. That's exactly what we want. So this is approach 4, which was successful. In approach 4, we used the built-in macOS sniffer tool. In fact, the sniffer tool is just a simple UI. Under the hood, it's a very useful macOS command line tool. It's called Airport. In this approach file, let's investigate why in approach number 2 it didn't work, but in approach number 4 it worked. And then let's see whether we can make the process more smooth so that we can run Wireshark directly instead of capturing the packets using sniffer and then just to display the packets in Wireshark. Let's see whether we can directly capture the Wi-Fi packets using Wireshark. Let's get started. So the Airport tool is under this super long folder, and the command itself is called Airport. Don't be confused about the very early Apple hardware for Wi-Fi. No, this Airport is just a generic tool and it works in macOS. If we run it, you can see it's a very long help. It supports a lot of arguments. Let's see what the information, the capital letter I as a parameter. It lists very useful information already. For example, the OP mode is crucial. Now it says station. Later you will see we want it to work in monitor mode so that we can capture the Wi-Fi packets. In the very last part, the channel 40 is the channel number. The -1 indicated the bandwidth. At this moment, you can see it's connected to this SSID, and if you go to the Wi-Fi icon in the menu bar, you can see it's solid white. It's working in station mode. Let's see how we can bring it into monitor mode. The way to do it is the parameter Z. But if you directly run it, you will see you don't have access. Just add a sudo. Use your administrator's password. Okay, no error. Let's display the current status again. See, it's changed. The state is INIT. OP mode is nothing now because we haven't started Wi-Fi capturing, so it's not in monitor mode yet. The current state means it's already not associated with the SSID. Association is the keyword here. In approach number 2, the root cause it didn't work was the OP mode was not really monitor, and at that time the Wi-Fi adapters was still associated with the SSID. That's why the Wi-Fi capturing didn't work, and that's why in number 4 it worked, because somehow the internal tool changed the OP mode. From the current information, you can see currently the channel is 1, not the channel we want to capture. Remember, we want to capture the channel 149 for AP1, right? The way to specify channel is using the C parameter. Directly follow the channel number without the equal sign. So I would say 149. Again, I need to use sudo. Run the information again. You can see the channel is 149. Now you may think we are ready to capture, but wait a second. Remember, in sniffer we also need to specify width. or bandwidth, right? But here you don't see it. Later we will see. For now, it seems we are kind of ready to start the capturing. So let me launch Wireshark. Try to start capturing. I select the Wi-Fi. Here you can see I still have the monitor mode selected. Then let's start. It's promising already, right? See the protocol is capturing 802.11, right? You may think we are done, we are good, right? But if you go to the menu item, see this menu icon is special. If you click it, you can see the Wi-Fi is on, but it's working in monitor mode. That's good sign. That's exactly what we want. If you continue, see the channel is 149, but the width is 20 megahertz. We want 40. So basically, yes, it is capturing packets, but it's capturing the wrong ones, not the bandwidth we want. So let's stop the capturing. Then let's go back to command line. Run I again. You see it's back to the active running mode, so we need to bring it down again. Z. Okay, I need to run in sudo mode. Run the I again. It's back to OP mode blank, and the channel is 149, right? Let's see how we can work around it to specify the width. AirPort only support the C parameter to specify channel. It doesn't have a parameter to specify width. But if we try to use the sniffer tool to capture the 149 channel with 40, let's see what's the channel display here, right? So let's do a test. I launch the sniffer again. This time let's specify channel 149 and width 40. This is what we expect the Wi-Fi adapter to work on. Let's start capturing. I just want to see how the sniffer specifies the width. Okay, it started. We don't really care about the packets. Instead, we just want to check the current information. See, this is how sniffer works. Yes, it set the OP mode to monitor for channel. If you don't specify the second part, if you just say 149, you will set it to 20 megahertz. But if you want it to work at 40 megahertz, you should specify the channel like this, right? Then you may think, okay, let's simply run the AirPort tool using this parameter as channel, right? Let's do a testing. So because we just stopped sniffer, the Wi-Fi mode is back to the working active mode. So we need to first bring it down, let it disassociate with the SSID, run the AirPort using parameter Z, display the current status. Okay, the channel is 149, which is not good. We want it to be 149,1, which means 40 megahertz width. I want to run the AirPort using this parameter just to mimic the macOS sniffer tools display, right? No error. Check the information. Nothing's changed. It's still showing channel 149. So basically that's a stopper. I couldn't find a way to specify the width, which means if you happen to be only interested to with 20 megahertz, good for you, because now you can already launch Wireshark to start capturing. But I want to capture 40, so it doesn't work for me. Okay, the approach file is kind of working, but if you want to specify the width other than 20, you cannot do it using this approach. It's a bummer because I really want the approach file to work. As you can see in all the file approaches we already talked about, I couldn't achieve completely satisfying results. Let me still show you one more thing, which is how I do it in Linux. I will use this Linux for this video. Before showing you the configuration, we need to first make sure our Wi-Fi adapter does support monitor mode. The way to do it is to run IW list. So it's a long feature list, but somewhere you should be able to find something called supported interface mode. As you can see, monitor is listed. So we are good. Our hardware does have the ability. Let's show the current configuration for the WLAN 0, which is my Wi-Fi interface, IWDEV. Okay, you can see the WLAN 0. It's not working in monitor mode yet, and the channel apparently they are not what we want want to use. Let's see what will be captured. In the left side, in Wireshark, let me choose WLAN 0 interface, start capturing. You can see from the protocol column, apparently they are not Wi-Fi packets, they are just Ethernet packets. Without changing the interface, apparently it doesn't work, right? So let's see how we can add our own monitor interface. Okay, in the right side, let me run a command. It's IW physical 0, then interface. Let me add a new interface called MON0 with type monitor. That's our new Wi-Fi interface just for Wireshark packets capturing purpose. So of course I need to input my correct password. Okay, now we have a new interface. We don't want the existing WLAN 0 interface to interfere our exercise, so let me delete it. So the way to delete a interface is to run IW command again, WLAN 0 DEL. Okay, it's deleted. The interface was manually created, so we need to manually bring it up. So I will run another command, IP link set mon0 up. Okay, it's up. Now let's run the IW device command again. Let's see what's the initial setting for this new interface. You can see it has type monitor and the channel width. Apparently they are not what we want. Our next step is to see how we can change the channel and the width. So this is the command we are going to run. You simply tell it the channel, which is 149. That's easy to understand. Remember, in macOS, we couldn't find a way to specify the bandwidth 40. Here, you do have additional parameters so that you can set the width, but it's not directly a number. Let's say 20, 40. You need to say HT40 minus or HT40 positive. I won't explain the details in this video, but you can do your own research. Basically, for each given channel, you can have some allowed combination of bandwidth. Even here, you set the parameter wrong. You will see the system simply doesn't allow you to do that. So let me try it. Let me try HT40 minus here. See? Simply tell you it's invalid argument. So let me change it. Let me set it to HT40 positive. No error. So we should be good to go, but let's validate the IW device again. Okay, see, the type is monitor, the channel 149, the width is 40. We are ready. So let's go to Wireshark and select the new interface, which is mon0. Let's start the capturing. If you scroll to the right, you can see it does have Promiscuous option, which is checked, but for monitor column, you can see it's disabled. Basically, from the UI, you cannot change the monitor mode, so you have to do it in the command line. Okay, let's start capturing. Yeah. Right away, you see the packets, and in protocol column, they are all 802.11. After the easy, straightforward command line changes, we are able to capture from the Wireshark, and we can see the packets in real time. We are done with the Linux part. Okay, in this video, we went through 6 different approaches from old Apple hardware, new Apple hardware, from the UniFi access point itself, or from Linux. Some of the approaches didn't work, some of them work, but are not very convenient, and some of them are better than the other. Thanks for watching.